Hello, this is Mr. Higgins again. We are doing exponential applications. This first one has to do with the college loan. It is accumulating an interest at the rate of 12%. So the first thing we want to do is to determine how much you will owe after X years of school. Complete the table and graph. So we're going to complete this table. Well, if we want to figure out how much money we're going to be owing, we got to consider that first we're going to pay the 100% of the 20,000, but we're also paying the 12%. And just like that interest problem we did at the beginning of exponentials, you're going to turn that interest rate, the 12%, into a decimal. And so when you do 20,000 times 1 plus 1.2, you're going to end up getting 22,400 for the first year. And then we're going to take that, and as y'all probably figured out, 1 plus 0.12 is 1.12. We're going to multiply that new number by the same amount, and you end up getting 25,088. We'll do the same thing with 25,088, and you get 28,098.6. And remember, this is dollars, so we can go ahead and leave it at 60 cents. Multiply that value by 0.1 or 1.12, and we will end up getting 31470. 31470.4. Okay. We're going to take that number and multiply it by that same 1.12, and we are going to get 35246.80. Multiply that number as well by 1.12, and we get 39476.5. Remember, these do have zeros at the end of them. They are money. And so one of the things you want to think about is whenever we are dealing with exponential functions, if you're trying to determine what the function is itself, we can always go back to the previous lesson determining functions from a table. The y-intercept here will give us an a value, and the ratio, well, if I multiply 22,400 by 1.2 to get 25,088, if I divide 25,088 by 22,400, I'm going to get 1.12. And it's going to happen each time we go backwards in our process. So the a value, that's 20,000. The base is 1.12, and then x to the x power. And if we graph that, it's going to be like right here, 1 and 22,400, it's about halfway. 2 and 25, it's about right here. 3 and 28, somewhere about right there. 4 and 31. 31, oh man, that's about right here. Okay. 35 with 5, that's about right here. 39, 4, that's real close to 40. And so it looks like this thing is linear, but don't let that fool you because the scale is way off. This is at a scale of 10,000, so half 10,000. It's at a scale of 5,000, while the years is just going up by ones. So even though it looks linear, it still is not. Suppose after graduating college you enter law school, how much would you how much would be owed after a total of 8 years? Well, we're gonna just plug 8 into our function and do 20,000 times 1.12 to the power of 8. And that value will give us 49519.30. So that's just taking 8 and plugging it into the x right here. And suppose after graduating you decide on medical school, how much would you owe after a total of 12 years? So we're going to do the same thing, except we're not going to plug 8 in this time. We're going to plug in 12. And that value gives us 77919.50. What is the domain and range of the problem situation? Well, your domain, it started here at 0, so you know that your domain can be equal to, oops, that's a horrible way of writing that, X that out. So the domain you get X is greater than or equal to 0 because it starts right here and it goes on forever. It could go on forever theoretically, at least the lifespan of the individual. The range, it started at 20,000. Okay, so there's your domain and range. This will be an example of a square root, or not square root, I apologize, an exponential application. All right, thank you. There will be one more example before we're done. Have a good day.